The Iron Man suit is a technological marvel, equipped with an array of advanced, miniaturized weapon systems. It makes for fantastic fiction and a basis for amazing storytelling, but in real-world physics, equipping the Iron Man suit with such powerful weapon systems presents significant challenges. In this episode of The Physics of Iron Man, we're looking into the suit's weapon systems to discover the real-world issues and challenges based on the laws of physics and thermodynamics. 1. Energy for the suit's high-powered weapons. One of the most fundamental challenges in miniaturizing powerful weapons like those seen in the Iron Man suit is the energy requirement to operate such systems. Many of the weapons depicted in the suit, particularly the repulsor beams and lasers, would require vast amounts of energy to function effectively in real life. Repulsor beams, which are depicted as high-energy blasts capable of knocking back opponents and destroying obstacles, would need a tremendous power source. Fitting such a power source into a wearable suit would require an energy density far beyond what modern technology can achieve. In the Iron Man suit, this power source is portrayed as the arc reactor, a fictional, seemingly limitless energy source. However, in reality, there is no known technology capable of generating the immense power needed to sustain high-energy weapons in such a small, portable form. There is no method, unrealized or realized, that could come close to providing the energy density required to operate the high-powered weapons like repulsor beams for extended periods of time without adding significant bulk and weight to the suit. 2. Heat dissipation. Laws of thermodynamics cannot be broken. High-energy weapon systems generate significant amounts of heat, and this is another major hurdle in the miniaturization of weapons in a suit like Iron Man's. In real-world applications, energy-based weapons such as lasers or directed energy weapons often face the challenge of managing the heat produced during operation. The Iron Man suit's repulsor beams, for example, would likely produce extreme amounts of heat, given the energy involved in firing concentrated blasts of energy capable of causing physical damage. Heat management is a critical issue for any weapon system, as excess heat can lead to overheating, which may damage components or even make the system unusable. Without efficient heat dissipation, the suit's exterior would become dangerously hot, endangering the life of the wearer. Heat generated by the weapon systems would also need to be directed away from critical components to avoid overheating or detonating explosive missiles within the suit. This would require a sophisticated thermal management system, another layer of complexity that would make miniaturizing weapons for a suit nearly impossible with current or future technology. Even if these systems could be incorporated, kinetic hits from Iron Man's opponents would most likely destroy these systems very easily. Protecting them would be nearly impossible, given some of the extreme damage Iron Man takes in his battles with supervillains. 3. Recoil and stability when firing weapons. In addition to energy and heat concerns, there is the issue of recoil and stability when firing high-powered weapons in a confined space like a suit. Real-world physics dictates that any time a projectile is fired, there is an equal and opposite recoil force exerted on the system that fired it, as per Newton's third law of motion. This means that every time Iron Man launches a missile or fires a repulsor beam, the suit would experience a recoil force that would have to be countered to avoid destabilizing the user. In real-world weapon systems, recoil is managed using heavy recoil buffers, or it is absorbed by the mass of the weapon platform such as a tank or ship. However, in a wearable suit, there is a significant limit to how much recoil the user could absorb before it begins to affect mobility or even cause injury. For example, firing a missile from the shoulder or arm would generate considerable backward force. While the structure of the suit may be able to handle this force, the person inside would still experience the effects of recoil. Without a system to absorb or redirect the force, the wearer would likely be thrown off balance, especially if firing weapons in quick succession. The suit would need an advanced gyroscopic stabilization system or thrust vectoring technology to counteract these forces, adding further complexity to the design, making the suit even more fragile. 4. Space constraints and miniaturization challenges. A major challenge in the miniaturization of powerful weapon systems is the space constraints inherent in a suit like Iron Man's. Advanced weapon systems such as miniature missiles, laser beams, or even physical projectiles requires significant space that is radically protected to ensure they do not detonate when taking massive kinetic damage from opponents. You would also need space for the firing mechanisms, storage for ammunition, and the power sources needed to operate them. Even in the most advanced real-world military hardware, these systems are large and bulky. Missiles require launch tubes, propellants, and guidance systems, all of which take up space. While Iron Man's suit manages to pack all these features into a sleek design, the real-world laws of physics present significant limitations. Each of these systems requires their own power and space, creating a design bottleneck where weapons would likely need to be downsized or sacrificed in favor of other essential functions. But the most limiting element to a functioning Iron Man suit, as we see in the movies, would be trying to protect all of these high-tech systems from the massive damage Tony Stark takes in battle. While the idea of miniaturizing powerful weapon systems within a wearable suit like Iron Man's is captivating, real-world physics presents significant challenges that make such a concept unlikely with any technology known or theorized. As it stands, the Iron Man suit remains a brilliant piece of science fiction, pushing the boundaries of our imagination, but far from being feasible in the realm of modern physics and engineering. Even if all of these systems could exist within the confines of a single suit, the enormous amount of kinetic damage Iron Man takes in the movies and comics would make protecting these sophisticated systems impossible. Together, Tony Stark and Iron Man make one of the best superheroes ever created that fires up our imagination, allowing us to escape into an exciting world of superpowered humans and villains. Iron Man will most likely forever stay in the realm of science fiction. We hope you enjoyed our exploration into Iron Man and his weapon systems, and invite you to watch our next episode,